The Department of Material Science and Metallurgy in Cambridge undertakes research at the highest international level of excellence. There are about 100 research fellows, postdoctoral scientists and visiting scientists in the department, and more than 140 research students studying for postgraduate degrees at master or PhD level at any given time.
I'm Aarti Vasudevan. I'm a PhD student in Material Science and Metallurgy. I started off by doing an MPhil in this department, and I continued on to do a PhD in Material Science and Metallurgy. As a child, I was drawn towards chemistry, and I wanted to be an engineer because I wanted to do things. And so I wanted to do chemical engineering, and I couldn't get into chemical engineering. So I thought I'll settle for material science, like metallurgical and materials engineering. And then, to my pleasant surprise, I found out that metallurgical engineering had a lot of chemistry in it. So what really drew me to material science was that metals and alloys are omnipresent. Like every structural component that you see is made of metals and alloys. And with the same composition, you could just tweak the properties with just heat treatment, and you get different properties from the same composition. So I was really drawn towards this microstructure process and property correlation. So that just kept me going, and I wanted to be a materials scientist. The main attraction of this department is the standard of its academics. So what's incredible to me is that I work with Professor Catherine Ray, and she is the professor of superalloys at the Rolls-Royce UTC in the department. Just to closely associate with her, interact with her on every week basis, and just share my results and gain knowledge from her is incredible to me. In addition to using lots of these equipment and learning to use them on my own is quite challenging and incredible. I think this is the place to be if you really want to learn something right and learn something deep and well. So there's indeed a lot of unlearning to be done, and you just need to have an open mind to grasp new concepts and just be in the right spot to understand constructive criticism and work on yourself. Just have an open mind. And I think this is the place to be if you really want to answer the question of why and how, not just what.
We nurture a positive research culture, and through training with world-leading academic research staff, as well as access to state-of-the-art research facilities, our graduate school has the mission to train the next generation of material scientists and develop advanced materials that will support the global challenges of climate change, energy and material sustainability, and the aging population.
I'm Marcel Moldavsky. I'm studying an MPhil in Micro and Nanotechnology Enterprise, which is a course both taught and by research. My domain is quantum devices, and I'm now into the research phase of my course, working on quantum computers in the Hitachi lab with my supervisor. The presence of material science in your everyday life is what raised my interest. When you scroll through your phone and you want to know what happens between the tip of your finger and the icon on your screen, that's something that drives me into this field. This proximity of material science in everyday life was something that drew me into this area. Material science at Cambridge offers those with creativity and business mindset the joy of abstraction, the joy of reinventing certain solutions on many different levels.
So I come from a chemistry background, and initially I wasn't particularly oriented towards material science, but the research projects that I was more interested in were all in this field. I completed a master's in nanoscience and nanotechnology in the Department of Material Science, and coming from chemistry, that gave me a better background and better understanding about the kind of fields I could go into for my research project. So I think what attracted me to material science in particular was that I was able to study both fundamental science and look at devices from a very scientific point of view, but also apply all of this to real world problems and real world applications. So really bridge that gap. between these two things, I think material science is a great place to do that.
Many of our PhD students progress to postgraduate research positions in UK or abroad, and many of our PhD alumni go on to lead their own research groups at top international universities or industry.
Hi, I'm Duncan Johnston, and I lead a data analytics group in the pharmaceutical industry. I did a PhD and also postdoctoral research in electron microscopy and analysis of that electron microscopy data. As I say, material science for me is really about applied physical science, using physical science to do stuff that's interesting in the world. And I wanted to come to Cambridge because I'd already got a material science background before that. So I knew I wanted to work in this area. I knew I wanted to work in electron microscopy, and I wanted to find the best place to do that work. And the great thing about Cambridge was that it had a new purpose-built facility for doing electron microscopy, which is fairly unusual. And that really provided the platform for all the work that I did in my PhD. The other thing, of course, is that working on a technique, you need to apply it to some materials. So you need to find people to work with who make materials. And this is a department which has lots of great research going on, so you can find loads of people to work with. So I had a really great time at the department. I really enjoyed being here. It's quite a small department in terms of its size, but the quality of the work that's being done within that department is really great. So there's lots of people that you can work with, even though it is small. And that means that it's tight-knit, it's got a sense of community, people are very collaborative, and that's great on the research side, but also in other areas like wanting to teach, supervise students, be mentored yourself. All of those aspects come into it as well, and it was a great experience overall.